A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Today's lecture will be under the module 6 and we will discuss about the construction aspects as well as the construction process for granular unbound courses. Now, at the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, typically in flexible payments, the unbound courses are constructed as sub-base courses and base courses. So, under that particular sub-base course and base course, the courses which are constructed are the most common one are granular sub-base course, and under the base course, the granular base course, unbound base course, we have the water macadam course and we have wet mix macadam. These are the most common popular courses which are used in the construction of flexible pavements for laying the sub-base courses and the base courses. Now, for this discussion, I will be referring the specifications for road and bridge works MORTS 2013, pocket book for road construction equipment IRC 2018, guidelines for wet mix macadam IRC 109 2015, standard specifications and code of practice for waterbound macadam IRC 19 2005, manual for design and construction and maintenance of gravel roads IRC SP 77 2008, then guidelines for wet mix plant IRC 26 2015. Many other codes will be also simultaneously referred. These are some of them which are listed here. Now, during the construction of a granular sub-base course, during construction of any pavement course, it is important first the selection of the material. You have done the selection of material considering the requirements as per standards and as per the project also. So, once you have ensured that the material quality is meeting the standard requirements which are stated in the codal provisions and which are also there in your project document. After this one, the next task comes with the design part, the combination which has to be planned, and then finally once that particular aspect is over, the next thing comes is the construction of that particular course. All these steps play a very vital role finally to achieve the desired performance from any pavement structure. So, when we are constructing a granular sub-base course, there are some key steps which are involved which needs to be carefully checked and monitored. The first one is preparation of the subgrade over which your granular sub-base course has to come up. Second is spreading of the granular sub-base course material, whatever material which you have selected, design, finally it has to be spread or laid in layers over the prepared subgrade. That forms the second, the spreading of the granular sub-base course material. And the third exercise specifically comes with relation to the rolling or the compaction of these layers to achieve the required density. And finally, to have a finished surface with any minor rectifications which are required is to be done before we proceed with the construction of the next layer over it. So, under the aspect of preparation of subgrade, the important part is before laying the sub-base course, the already prepared, because we have already prepared the subgrade top, the prepared finished subgrade should be cleaned because there may be some amount of delay between the preparation of subgrade top and when the construction of your granular sub-base course has started. So, during that particular delay, if some amount of changes has happened, specifically some because it may be a rainy season, some amount of vegetation has been grown up, or there may be some movement of vehicles, uncontrolled movement of vehicles which has happened, which may have loosened the topsoil. So, in that case, what we will prefer, we will prepare the subgrade in terms of removal of any vegetation or unwanted materials which is there, and if needed, it is if there has been a gap between the construction of the subgrade top and the laying of granular sub-base course, it is always preferred that the surface can be lightly sprinkled with water and one or two passes can be given with a smooth wheel roller. So that ensures a good surface to take your granular sub-base course material. So the prepared subgrade should look in this particular manner. There should be no unwanted materials present over it, and it is always better to sprinkle water and give 1 or 2 smooth passes to get a good firm foundation for placing your granular sub-base course material. Now, we already discussed, since MORTH recommends 6 gradations, so the one of the gradation as per the codal requirements and as per the project requirement has to be picked up and ensured for the physical characteristics. Thereafter, the water content, as we determined with respect to the IS 2720 part A, has to be worked out, and this water has to be added pre-mixed with your granular sub-base course material. So, and this mixing can be with harrows, with rotary mixers, pre-mixing to the required your optimum moisture content is to be done, and then this particular one is to be spread out. So, water content as determined in accordance with IS 270 have to be mixed mechanically by a suitable mixture. Sometimes grader is also used with provision for controlled addition of water and mechanical mixing. So, there should be mechanical mixing. This is important. It should not happen manual mixing is going on for this granular sub-base course material. And once mixed with water, it should be spread over the prepared subgrade. Here plays a grader, a fantastic role is played, and having an adequate capacity. Capacity means to the width which is required, it can spread depending upon the hydraulic the blade which is there. You can go for wider widths of it. So, the grader should have a blade with hydraulic controls to set and maintain the cross slope and grade during the operation. As we have seen, some of the, when we are constructing 2 layers of sub-bases, will preferably go for the upper layer as our drainage course and the lower layer as filter course. So, this is important, and when the thickness is less, the combination of a filter cum drainage layer can be provided. But it is important that this drainage layer or the granular sub-base course should be as per the required cross slope, because when it is to be constructed, and we are maintaining the cross slope from the subgrade construction itself. So, again when you are constructing one individual layer, this needs to be ensured. So, the grader will spread the material as per the required cross slope on the prepared subgrade. The moisture content of the granular sub-base course is to be checked, it is to be ensured, because now this loose material is to be compacted and adjusted specifically, because when you are going to mix it and then finally when it gets compacted, there may be around 1 to 2% water content which may be less than what is your optimum moisture content, and which is good for your compaction also. The water, it should not be having excess water. If excess water is there, then OMC, then the surface needs to be aerated before you start the rolling process over it. Now, to take up with the rolling process, once it has been spread to the required cross slope using a motor grader, then we have to start with the rolling process, and it has to immediately start, because otherwise there will be loss of moisture content will be there, which will make your compaction difficult, and it will may lead to an inadequate density also. So, it says if the thickness of the compacted thickness is less than 100 mm, we can preferably go with a smooth field roller of 80 to 100 kilonewton weight. But usually we construct granular sub-base courses of thickness around 200 mm. So, there we prefer to use vibratory rollers of 80 to 100 kilonewton static weight. So, this is a selection of the rollers based on the thickness which you are constructing. Now, when this rolling process has to start, if you are having, say this is the width which is there, this may be your center line which is there. So, it appears like we are doing a 2-lane construction, or it may be a 4-lane construction, center line is there without any median. So, in this particular one, there will be a camber in this manner, there will the crown will be here, the sides will be at a lower level compared to this one. So, this is like a cross section here which is drawn. So, this middle part is raised and the edges are lower down. if this sort of thing is there, then you will prefer to start your compaction from the edges and you move towards your camber. And so this will happen, and for both the directions, you will do for this direction also, you will do for this direction also. You will start from edges and you will move towards camber. If there is a, say, a curve is there, this is what. In this particular one, there will be a super elevation. Super elevation means if I draw a cross section here, this particular edge will be raised and this particular edge will be at a lower level. So, in this case, when one edge is at the raised level, other one is at a lower one, we will start the compaction from the lower edge and we will proceed towards the upper edge. So, this is a compaction pattern which has to be followed to ensure a uniform and an adequate amount of density to be achieved. So, it says rolling shall commence at the lower edge and proceed towards the upper edge longitudinally for portions having unidirectional cross slope or super elevation. So, this refers to this one, where it starts from lower edge and proceeds towards the upper edge. For a carriageway having cross slope on both the sides. So, this refers this case. Rolling shall commence at the edges and progress towards the crown. So, this is how the rolling pattern. This rolling pattern is also important to ensure a uniform and a proper compaction. Now, during this compaction process also, we normally prefer to have the speed of the rollers less than around 5 km/h, and the cross slope, as I mentioned, is very important, and the not only this layer, even the other layers also the cross slope is very important, but here the granular subbase courses when are playing the role of drainage layer also. So, here it becomes very important to ensure this particular one. So, it says the cross slope and surface levels have to be continuously monitored for any irregularities such as bumps or depressions, because that should not happen with any of these granular subbase courses. If it happens, if at certain locations you are able to figure it out, there is some excess material, it should be trimmed out, your graded blade can do it very well. If you are finding that some there is a lack of material at certain locations, some excess material with proper gradation, it should not be there that you are only putting fines there or you are only putting coarse there, because this will alter your gradation and which can hamper your performance of that particular layer. It says each pass of the layer shall overlap at least 1/3. So, when, as I mentioned, if I have this particular one, this is my crown, if I am proceeding. So, when this is one pass, then when it comes for the second pass, it should already the existing one should be overlapped by the 1/3 of it. So, you can see how the rollers will be moving in the field. They will be moving in a pattern. We have multiple rollers which compact this particular one. So, they move in a manner that the drum of the rear one have an overlap of 1/3 with respect to the one which is moving in the forward direction. So, this is how we try to ensure that there is an overlap of at least 1/3 of area compacted in the preceding pass. So, rolling is continuing till the here it is the soil, or normally this is the granular subbase coarse material which is there, which reaches to a density of 98%. So, now this density already we have determined, where we have determined our OMC and MDD. So, the density is to be simultaneously ensured, as we discussed that we can do it by sand replacement method or some non-destructive testings, where we can use the nuclear density gauges or non-nuclear density gauges to monitor that the density of your granular subbase coarse material is at least 98% of the one which was there in the laboratory determined maximum density. The surface of any layer of material on completion of compaction shall be well closed. Now, you can very well see once the surface gets compacted, you can see a good surface finish material, and while compaction also you can observe if the material is moving there in front of your the roller, then the compaction is not good enough specifically. Over rolling is also harmful because it breaks down your aggregate. So, breaking down of those aggregates results into change of your gradation. So, that is why it is under rolling and over rolling, both are harmful. We need to ensure this particular one, that around a range of 98% of the density is achieved. So, the surface of any layer of the material on completion of compaction shall be closed, free from movement under compaction equipment. When this compaction is completed, you can see there is no material movement you will observe. And from compaction planes, because when one pass is there, one pass will go, you will see there when these passes are there, this pass will go, then there will be a plane which will be formed. When the next pass comes having an overlap of 1/3 over it, when this keeps on continuing, after a certain period of time, you will find that these compaction planes or ridges are removed, and there should be no loose material which should be lying on the surface. So, that makes your surface or the granular subbase course ready to take up the second layer, which may be again of a granular subbase course material or a material which can be of a base course. Now, there is another very popular course which is used, that is water-bound macadam. This water-bound macadam is also used as a subbase course also and as a base course also. And we have earlier discussed about its requirements. The water-bound macadam course comprises of clean crust coarse aggregates, because first in this particular construction we are going to put the coarse aggregates on the prepared surface. Now, here the prepared surface, if it is used as a base course, the prepared surface will be a sub-base course, and if it is directly put over subgrade, then the prepared surface have to be a subgrade top. So, it comprises the coarse aggregates which are first applied under the construction of a water-bound macadam course, should be clean crust coarse aggregates that are mechanically interlocked by rolling. So, what is done? We put those coarse aggregate and rolling is done over those coarse aggregates. Thereafter, you apply the screening material or the binding material, application of water is there, simultaneously rolling is there. So, that fills those screening materials and binding materials, fills up the voids and gives you the desired water-bound macadam surface. So, it says water-bound macadam course shall comprise clean crust coarse aggregates that are mechanically interlocked by rolling and voids thereof filled with, and the voids in these coarse aggregates will be filled with what? By screening and building materials with the assistance of water. That you will require, water you will require, laid on a prepared subgrade. If I am using the water-bound macadam as a sub-base course, then it will be laid over a prepared subgrade, or it can be on a sub-base course also, or a base course also. And even sometimes when we are going for strengthening of certain pavements, you may have to construct a base course. So, existing there may be some bituminous surface over which you may have to construct the water-bound macadam course. For that, in those cases where the existing is a bituminous top, certain precautions has to be taken up. We will discuss in the upcoming slides. Otherwise, mostly it is preferred as a base course. So, it will be constructed over a prepared sub-base course. Now, what are the key steps which are involved specifically in the water-bound macadam construction? First is the preparation of the base, which may be your subgrade top or your granular sub-base course. Then preparation of a drainage course, specifically depending upon if it is laid over a prepared subgrade directly. Lateral confinement of aggregates, coarse aggregates are laid and compacted. So, during the compaction of the coarse aggregates, the edges of those coarse aggregates have to be confined well for proper compaction. The spreading of coarse aggregates, and they should be well spreaded up to the desired quantity which are specified by the project document as well as the MORTH guidelines. Then the rolling of the coarse aggregates takes place. Thereafter, application of your screenings is there. then followed by sprinkling of water, which allows the screening material to go inside the voids, simultaneously followed by compaction, and this screening material goes inside the voids and the grouting of those voids is done. Wherever further requirement of binding material is there, that is again put over it and compacted with the application of water. Finally, it is allowed to set and dry and checked for any surface irregularities or surface defects, so as to achieve finally a finished surface for the next layer to be constructed. So, in this particular one, as in case of other layers also, the important part is the surface where the WMBM course is to be placed should be first brought to the correct grade. Why? Because this may happen that you have constructed a subgrade top or a granular subbase course few days back, and there was a time gap before coming up for the next layer. So, you might be doing say a subbase course construction for an entire length of 10 kilometers. Once that subbase course construction is over, then you have come back and started with the waterborne macadam construction. So, there may be a time gap between the one surface which was prepared and then the next layer when it is going to come up. So, in that case, the existing surface, because of any reason, if any movement of vehicle, any growth of vegetation, anything or any construction movement of any construction vehicle, if it has damaged, it has to be rectified, corrected to the grade and camber and cleaned for any dust, dirt, unwanted materials. So, it should be ensured that when you are putting up the next layer, it should not, the existing layer should be in a proper manner, or it should be in a good foundation stage. Also, if any ruts or soft spots are found, because if say there may be a rain, if at certain locations if standing water is there, it will make your material soft. So, before you go for the construction of the waterborne macadam, it is important that you aerate that particular one, again aerate it. If material is required, you need to mix with it, and then you compact it to bring it to the required density and grade before you put up your next waterborne macadam course. So, also if any ruts or soft spots are formed, then they should be fixed and rolled until the surface becomes firm and stable to receive the waterborne macadam course. The existing road surface should be scarified and reshaped to the correct slope and level before laying the course aggregates. If you are finding, if any defect is found later on, if you are able to see, okay, the levels were not properly ensured, and you find that this course is having levels which are higher than what is there for the top of a granular subbase course, then you need to rectify it at that particular stage, and then you will go for the construction of the waterborne macadam course. This has to be ensured for all layers. The tolerances are already given. If the things are out of those tolerances, rectifications are to be done before coming up with this new construction of new layer. Again, as I mentioned, when the WBM course is constructed over an existing bituminous layer, challenges arise because there will be a issue specifically with the internal drainage between your existing bituminous surface and the waterborne macadam layer. So, at that interface, because we are constructing the waterborne macadam by using the application of water, so that water may be there in the layer between the which you have between your existing bituminous and the waterborne macadam course. So, it is always preferred if you have a thin bituminous surfacing, which normally is there when we are looking for rural roads or low category roads, low volume roads, there it is always preferred that you remove that thin wearing course, because you are doing strengthening, because already the surface might have shown some amount of distresses. So, better to remove that thin bituminous surfacing and then go for the construction of your waterborne macadam over it. Now, as mentioned, if in certain cases, if you are using the waterborne macadam as a subbase course, which you are placing directly over the subgrade, then it is always preferred that if WBM course has to be placed directly over the subgrade without any layer in between, a 25 mm thick layer of screening. The screening material gradation is already specified. This is the screening grading B of waterborne macadam itself as specified in MORTS 2013, or any coarse sand having a thickness of keeping a thickness of around 25 mm is layered between the subgrade and the WBM as the separation layer. So, in case and if the soil is silty, specifically fine sand or silty or clay subgrade soils are there, or the subgrade is constructed using these kind of soils, it even recommends for a 100 mm thick layer of screenings or coarse sand over fine grained soil. So, this because there should be no intrusion of the soil particles into your waterborne macadam course. So, we will prefer to go for laying a layer of a screening material, and the thickness will be depending upon the type of subgrade soil to be over which this waterborne macadam course is going to come. And in certain cases, if the project allows, it is always preferred that we go for some combination of geosynthetics. As we discussed in one of the earlier lectures, you can have a geocomposite where you have a geotextile on the lower side, you have a geotextile on the upper side, and you have a geonet. So, this geonet serves the purpose of allowing the drainage of water, and it serves the purpose of both your filter come as a drainage layer. So, if the project allows, it is always preferred to go for some construction of a geocomposite layer, which will serve both the purposes. So, it serves the purposes of drainage as well as your filter cum separation layer. Now, once the existing surface is ready, then you put up your spread the coarse aggregates for your waterborne macadam course. So, for WBM construction, side support for the aggregates is preferably provided by building the shoulders. So, it is good that you start your simultaneously construction of your subgrade. So, good enough to build up your subgrade simultaneously. This subgrade layer will be able to provide a confinement to, otherwise see, if this is my edge of the coarse aggregates, there is no confinement on this particular size. If there is some confinement in other manner, this is a curved wall which is there. Otherwise, I will prefer a raised subgrade construction along the edges of it, so that when the compaction is getting done over the edges, there is no shift of material which is happening at the edges, and this will allow me to achieve a good compaction at the edges. So, I will try to ensure to protect the edges of my this granular subbase coarse material which is spread here. So, coarse aggregates are spread evenly over the prepared subgrade or subbase. This is very important. How these are? I will always prefer some mechanical means for spreading these coarse aggregates, so that there is a uniform spread, there is no segregation which happens over it, and preferably a thickness which is not more than 75 mm. So, the coarse aggregates, so here you can see a motor grader is used for spreading it out. It helps you to maintain the cross slopes also, and along with it I can use templates, so as to ensure that the thickness is what 75 mm I am trying to achieve. So, I can put up some templates placed at intervals of say 6 meter across the width of the road to ensure some levels while spreading this particular material, that okay, the required thickness has been spread over it. Wherever possible, aggregate spreaders should be used. Nowadays, these are very common equipments which are available at construction with many contractors. So, I always prefer to go for aggregate spreaders, so that they can spread aggregates evenly, and this will allow to minimize the need of manual rectification, because otherwise the things becomes more challenging at a later stage when some segregation is there. So, the segregation of coarse aggregates is to be avoided, and this can be done by avoiding manual spreading of the WBM coarse aggregates. Better to go with spreading through some mechanical means. Uniform gradation and spread shall have uniform gradation with no pockets of fines. Otherwise, segregation means coarse comes at one side, fines remains at one side. This is what segregation is. They are different sizes, they are not properly, all blend is not present in that case. The surface of the aggregates spread shall be carefully checked for any high or low spots. Simultaneously, as templates are also there, we can move around on the surface and can ensure if some local depressions are there or some certain locations where some excess material is there, it can be removed or added in the beginning itself. So, you can see a surveyor exercise is also simultaneously going along with the spreading of the aggregates with your motor graders. While spreading and rolling, and then you start the rolling of the surface also, the surface shall be checked often using a straight gauge to make sure it meets the appropriate your surface level requirements. But if you have a good control with your grader, mostly you are able to achieve the levels in that case. Simultaneously, your surveyor will do some exercise, templates are also there. So, if these multiple checks are there, you will definitely achieve the required levels. The coarse aggregate shall not normally be spread more than 3 days in advance of the subsequent. Now, this is important. It should not happen that you have spread the coarse aggregates and then the next stage of construction is delayed for some period of time. So, that is not required. You have to, the important aspect is when one layer is constructed, the entire exercise of those involved in that one layer should be completed simultaneously. So, once the coarse aggregates are spread, thereafter you start the rolling process. So, immediately after so it says forget about delaying, we should prefer to go for immediately the rolling operation after the coarse aggregates are spread. Rolling should commence using a 3-wheeled, you can use a 3-wheeled roller, a tandem roller, a vibratory roller having a weight between 80 to 100 kN. So, different rollers we discuss. So, you have availability of the rolling pattern is to be ensured that when you here in this, when you are rolling the coarse aggregates, the pattern is to be in the same manner. You have to follow from, if there is a camber, a crown at the middle, from edges to the crown. If there is one side slope is there, then from the inner edges or the lower edges to the outer edges. On super elevated sections, so it says rolling preferably starts from edges and move towards the center when there is a crown. On super elevated sections we discussed, on roads with one-way slope, this is a one-way slope. So, here I will prefer to start from the lower edge and I will prefer to go towards the upper edge. So, start from the inner edge, and this is what we call as the inner edge. Inner edge, because when we move along these horizontal curves, this will be at a lower level, this will be at a higher level. If I cut down the cross section, it looks like this manner. So, always it is said that it should start from the inner edge and goes towards the outer edge, or I can say from lower edge and goes to the upper edges. So, the edges are to be compacted first by rolling forward and backward, and so we will first prefer to roll these edges, because so that the material gets a good support from the compacted width of it. So, we will prefer to go for some, and the edges again needs to be protected. So, we will then roller should move inward towards the center in overlapping passage, and here it says for this particular one coarse aggregate around a overlap of half of the width of the previously compacted width should be there. So, there should be an overlap, which earlier was 1/3 in case of granular sub-base course. When we are compacting the coarse aggregates for waterborne macadam, the overlap should be around half of the width of the previous pass. Now, once this rolling operation is done, thereafter we come up with the spreading of screenings and binding materials. But there are certain cases, if we are not using, if you are using some weak aggregates or soft aggregates specifically, in those cases we do not go for screenings. So, screenings are usually not used when materials like brick metal or lateral or canker are used. here in this case, then because they themselves gets crushed during this compaction exercise, so you don't need to put up any screenings to fill up the voids. They themselves get crushed and the fines fills up the voids between this particular one. And but then you have to be very careful that there should be a proper filling of these voids should happen, so as to give a tightly packed and locked in place aggregates. So this needs to be careful. When you are using these soft materials, you have to be more careful. Otherwise, the materials, specifically in soft materials, they crush down, the rolling is done along with a light sprinkling of water, so that these screenings further get the fines which are getting created with these soft materials get further packed in a good manner to give you a good desired surface. Otherwise, if you are using good quality of aggregates, then your crushed stones, then you will be doing the application of screenings and binding material as per the requirements. So after in normal courses, when you are using crushed stones, after the coarse aggregate compaction, screenings are gradually spread over the surface. So these, and then again there are two gradings of screenings are specified, and there are quantities of coarse aggregates also specified, quantities of screenings are also specified, and quantities of binding material is also specified. So as per the codal specifications and project document, that has to be picked up. So then after and if there is some contradiction which is found, then the engineer in charge should be taken into confidence to decide which one is to be picked up based on the experience and the one which gives you a good performance. So after the coarse aggregates compaction, screenings are gradually spread over the surface to fill the gaps between the stones completely. So in a small scale projects, this spreading of screenings can be done in manually also, but it is always preferred that mechanical spreaders should be used, so that a proper spreading of these screenings is done. The screening shall not be damp or wet at the time of application. This needs to be ensured, otherwise they will not go inside the voids. So they should not be damp specifically when they are spread over the surface. Dry rolling is done while the screenings are being spread. Simultaneously we do the drying rolling, and this process goes in simultaneously. So some amount of screening is spread, rolling is done, then some amount of screening material is spread, because finally to achieve the required quantity of screening, so we will do this screening application, rolling simultaneously exercise, so that by that vibrations, by that rolling compactive effort, the screening material goes inside the voids. So that vibrations of the rollers cause them to settle and fill the voids of the coarse aggregate. So this is again an intelligent exercise which has to be taken care while making the application of screenings over the compacted coarse aggregate bed. The screenings are not to be dumped in heaps. This is another concern. That is why it is said, even if it is spread manually, it has to be carefully spread. A heap of screening material should not be created in any place, so it should not be dumped. It should be spread over the coarse aggregate surface. Instead, they must be spread evenly in thin layers using hand shovels. If a small project is there, mechanical spreaders always preferred, or directly from a tipper, or in that particular case, the one carrying the screening material have certain arrangements. Many of them nowadays have arrangement. They can spread the material along the width, and this can be controlled. So the spreading we can done directly from the tipper only, which is having that screening material with it. So this tipper with a proper grit spreading setup is there. Many of them are coming up with those attachments nowadays. There has been a lot of advancement which have been attained in the construction equipments also. So spreading, rolling and brooming and if you will find at some places more material is there, then you will broom it. This exercise will try to disperse your screening material within the voids of your course aggregates. So, brooming of screenings are carried out in such lengths of the road which can be completed within 1 day's operation. This is always, as I mentioned, will prefer to complete one course. We can pick up a length, say it may be a 500 meter length section or a 1 kilometer length section, 5 kilometer. Important part is, depending upon your production capacity, depending upon your construction equipment's availability, how many tippers you have, how many rollers you have, how many manpower you have. So, depending on that particular one, you should pick up a length which can be completed in 1 day's exercise. So, following the application of screenings, the surface has to be thoroughly sprinkled with water. Now, here comes the important exercise. Now, the water is sprinkling. So, for again you need to have the proper distributors or sprinklers with you, so that it spreads water in a uniform manner. It should not happen that at one place more water is poured compared to the other places. So, there should be non-uniform distribution of water should not happen. So, we will consider these distributors, water distributors with proper nozzle arrangements or sprinklers which are there. So, with water swept clean and then compacted, and then again the compaction process goes over it. So, hand brooms can be used to sweep the wet screenings into voids, and simultaneously hand brooms, so that it pushes your screenings within your air voids and to distribute them evenly. So, if you are finding that at some locations again there are certain spots which are having more of screening material compared to the other spots, these hand brooms, mechanical brooms can be used to distribute that one evenly. The sprinkling, sweeping and rolling operations are continued with additional screenings as and where felt necessary. Where excess, it can be removed. Where you find, because we have already the controlled quantities that have to be spread in a particular length, because it says in how many kilometer area, how many square meter of area, how much quantity is to be spread. So, that is already controlled. So, we need to spread it out, because those are well determined, stated in our specifications. Until the coarse aggregates have been thoroughly keyed. Now, because of this one, these screenings will go inside the voids with the help of compaction, with the help of the water, and will lead to a well bounded and firmly set coarse aggregates through their entire full depth. And this has a grout has been formed of screening. So, this what screening has gone is like we say cementitious grout is there. So, this screening is acting as a grout to hold your coarse aggregates together. So, care is to be taken to ensure that the subbase or subgrade does not get damaged due to excessive quantities. This happens if there are not proper distributors, water distributors are there, and if you directly open up a mouth, normally if you do it with one pipe and you spread it manually, so there may be a lot of water which may uneven distribution may be there, and that water may go down and may hamper your underlying layer, which may be your subgrade layer or any subbase layer. So, that should not happen for that particular one. Nowadays, these water tankers or one which are having these attachments for uniform distribution in terms of sprinklers or distributors are very common. So, they should be used for this particular exercise. So, we can see the screenings, water application and the rolling simultaneously going on. Once this application of screenings is done, there in certain cases binding material application is also required. There also, as I mentioned, the quantities of binder materials are already specified, that this much quantity of binding material has to be put over it. So, the binding material as required as per the codal documents, or as many a times it will say as per the MORTH guidelines. So, there it mentions that how much of binding material for a particular grading of screenings is to be used, or how much of binding material quantity is to be used. And staitage is applied successively in 2 or more thin layers at slow and uniform. Now, this particular again it has to be applied in thin layers, in at least 2 to 3 layers is to be applied, so that finally it goes inside the voids and gives you a good surface over it. after each application the surface shall be sprinkled with water. So, once the binding material is applied, and again the water distributor is to be used for uniform sprinkling of water, and the resulting slurry is swept into the voids. When this, you can see a slurry will be formed with this particular one with binding material and water, and we will prefer using mechanical brooms or hand brooms to that this particular one, the slurry goes inside the surface voids while this compaction exercise is going on. The surface is then rolled, preferably with the application of water, and when this exercise is done, this slurry sticks to the roller drums also. So, we put some, but judicially, or we will use wet jute cloths, or we will sprinkle water, but that should not be in high quantities, otherwise again the excess water will create a problem for the ongoing layer also, as well as may damage the underlying layers also. So, some application of water is required specifically to clean these drums. Roller wheels as needed to prevent binding material from adhering to them. These operations shall continue until the resulting slurry after filling of voids forms a wave ahead of the wheels. Now, when all these voids will get filled, whatever this fine binding material which is there in the form of slurry because of water, if there is no further requirement of it or no space for this slurry to go inside the voids, then it will start moving during the compaction in front of your roller drum. So, then you can understand that even this there may be certain quantities, you can stop at that particular one, considering that all your voids got filled up with the screening and then your binding material. So, you do not need to go for further application of any binding material. So, there a range of quantity is given for binding materials. So, while construction, that needs to be ensured by your monitoring of that particular surface. So, once this particular exercise is done, you have ensured now that all the surface voids are filled, the binding material is enough. Now, the compaction is completed. This surface have to be left for overnight, specifically to make it dry. So, and then the next day we can come on the next day and can see if some hungry spots are there, then we can put up some binding material there, and we can put up with binding material along with some small sprinkling of water, and we can repair those particular one. We can look for any hungry spots, and if we find that there is some excess material is there, if it needs to be, and some excess water spots are there, spots which are holding good amount of water, it may require to get aerated also, or you have to leave it to dry for more number of hours. So, this needs to be next day. Immediately construction should not be carried out over a waterborne macadam till it gets dry. This is very, very important. So, waterborne macadam surface is left to dry at least overnight, and on next day any hungry spots found are filled with screening or binding material, then lightly sprinkled with water if required and rolled. So, then this has to be next day, we need to ensure for it. But the important aspect is waterborne macadam is to get completely dry and set before the next pavement course is laid over it. This is an important exercise. If this is not ensured, the water remains trapped inside that particular layer, and if it is used as a base course followed by a bituminous course, it will damage your the upcoming layers. So, it is very important to ensure whatever water is there, that layer becomes dry, and then you proceed with the construction of. So, you need to plan your construction activities in such a manner. The entire WBM layer construction gets completed in one day job. So, depending upon your availability of construction machinery and the stretch which is available with you ready to take the waterborne macadam course, you need to ensure that the work gets completed in one day. So, this is what about the construction practices related to the granular subbase course and the waterborne macadam course. In next lecture, we will start the discussion with the construction of wet mix macadam. Thank you so much.